Hello friends, welcome to Power Electronics. Today we will discuss the Class B commutation numericals. As in the circuit we can see that Vs is the source voltage, C is the capacitor, L is the inductor, T1 is called as the main thyristor and T is the auxiliary thyristor. This is the load and D is the diode. As we have already discussed in the previous class about the this class B commutation. But in the question, it is asked to calculate the conduction time of thyristor TA. So I will explain it again. Before the thyristor, before the circuit was on, the capacitor was initially charged with the value of Vs with a polarity plus minus. As you can see, at that particular time, the thyristor T1 and thyristor TA was not conducting. The current flows through this path and this capacitor gets charged to the value of Vs. After that particular point of time, the current starts flowing to the thyristor T1, that is called as main thyristor, then to the load and then to the back path. Now the capacitor has no path to discharge. The reason is that the source voltage and the capacitor voltage is same. So both the potentials are same, so the current will not able to flow. But this condition changes when the auxiliary thyristor is fired. As you can see in the diagram, it is fired at the instant T1. Also, it gets turned off at instant T2. So how it get turn off and turn on? When it is triggered by the gate pulse IGA, a thyristor, auxiliary thyristor starts conducting. Now this capacitor have the path to discharge. This discharge through this path to an auxiliary thyristor, then it passes to inductor and capacitor. This is the path. As you can see in the diagram that load current is also constant. The current flowing through this thyristor is also constant. Charging current has no path to flow in previous, and the capacitor voltage is already charged to the voltage of Vs. But when the auxiliary thyristor is fired, now the condition changes. Here the current has no effect, that load current is always constant and thyristor is also constant current flowing through it. But here the charging current IC is flowing in the negative direction because its polarity is marked here. It is flowing in the opposite direction, so you are getting this curve. So voltage across capacitor is reducing to, it start discharging and get to a value of 0. Once it completely gets discharged, now the polarity changes. Now the current flows through this direction through diode and thyristor. Here the negative sign will turn off this thyristor. So at instant T2, that auxiliary thyristor gets turned off. In between this, the time period is omega naught T pi. So omega naught T pi. So here T is equal to pi upon omega naught. We can calculate our first question, that conduction time of auxiliary thyristor. So it is T upon omega naught, where omega naught is called as the resonant frequency. Also in the next question it is asked the voltage across the main thyristor when it gets commutated. So what voltage we get across the main thyristor? This is called as the main thyristor, which is T1. This T1 is the main thyristor. So to calculate it, its formula is omega naught T3 minus T2 sine inverse upon load current upon peak current. So as you can see in the diagram that the instant from T3, here this is the instant T3 and this is the instant T2. In between the thyristor gets commutated. As you can see here in the thyristor IT1, here the thyristor, here at the point it starts decreasing and reaching a point 0. What happened here? The polarity was changed after the capacitor gets discharged. Now the current flows through this, through the diode and from this thyristor. It is not flowing in the load current because the charging current is higher than the load current. So what happened, the thyristor gets commutated. So when it gets commutated at the instant t2, here the instant is t3. From t2 to t3 it gets commutated. So its formula is its resonant frequency into time period, that is t3 minus t2 into sine inverse of I naught upon ip, that is peak value. So load current in question, it is given 230, sorry, it is given 300 ampere, and peak value we will calculate by this formula, ip equal to vs under root by lc. So 230 volt is the supply voltage we have given, capacitor value is 20 microfarad, and inductor value is 5 microhenry. So we will calculate, we will get the value of 460 ampere I naught. We will put this value here. Also in the next question, we have given that circuit turn off time of the main thyristor. This circuit turn off of the main thyristor, I will explain this. This thyristor T1 gets turned off at the instant of T3 minus T4. This is T3 and T4. As you come above, the thyristors get completely turned off. That is called as the main thyristor T1 completely gets turned off. That's why we called it as the circuit turn off time. So we will calculate all these numerical values here. This is already a solved example of PS Bimra. The peak value of resonant current, what we get, ip equal to vs, that is 230 upon this capacitor voltage 20 upon 5. So we get peak current 460 ampere. Also when we calculate here, put the value of L and C, we get this omega naught. Also the conduction time of auxiliary thyristor we have calculated is 31.416 microsecond. Also voltage across the main thyristor, we got it, its value is I think its value is 40.706. Then we have to calculate VAB, that we have to put in the circuit turn off time of the main thyristor. We calculate by Vs cos omega naught T3 minus T2. Vs we have know it is 230. Cos value omega naught we have already calculated, and T3 minus T2 we have calculated the voltage here. Also circuit turn off time is Tc equal to T4 minus T3 equal to C VAB I naught. So value of the capacitor upon VAB we have already calculated upon I naught. So what is the main purpose for solving this question? It is already solved. Here I want to show you that you can see the conduction time of auxiliary thyristor is 31.416 microsecond. Also you can see the circuit turn off time of main thyristor, which is 11.624 microsecond. So it is very less time required to turn off the main thyristor. Auxiliary thyristor conducts for a longer period of time. That I want to explain with this example. This is solved example. You can see an auxiliary thyristor conduction and turn off time is very large. You can see this is the time period, but when it comes to the turn off of the main thyristor T1, that you can see it turn off at that point of time from T4 minus T3. Here T4 minus T3, at that instant it turn off very fast than the circuit. So we always have to keep the thyristor T1 turn off time very small turn off time, so that our main thyristor won't get damage. This is our main thyristor. Auxiliary thyristor, it can conduct, it is always designed for the higher values, but for the thyristor T1 it should conduct in a very, it should that commutate at a very shorter period of time. You can see it is 11.62 microsecond. Thank you very much.